Stop pouring that super expensive premium gas into your daily driver. Seriously, you are throwing away 40 to 60 cents on every single gallon for absolutely no benefit. And the oil companies love that you believe the lie that higher octane means a cleaner, faster car. It doesn't. And I'm going to show you exactly which cars actually need it, which cars are completely immune to it, and how you could be doing more damage to your engine by obsessing over that high-test fuel than by just using regular, cheap gas. The truth about octane is way simpler and way more controversial than anyone at the pump will ever tell you. Intro, you drive up to the gas pump and you see the three options. Regular, usually 87 octane. Mid-grade, maybe 89 or 91. And premium, usually 93 octane. You look at the price difference, maybe $7 or $8 more to fill up the whole tank with premium, and you think, well, I love my car. I want it to run great. I want it to last forever. I'll spend the extra money, it must be better, right? That is the oldest, most profitable marketing trick in the automotive world. For most of you watching this, that extra money is a total waste. It does absolutely nothing for your car's performance, fuel economy, or longevity. The key takeaway you need to understand is this. Octane is not a measure of fuel quality or energy. It is a measure of the fuel's ability to resist compression before it spontaneously explodes. And unless your engine is designed to squeeze that fuel hard enough, it literally cannot tell the difference between 87 and 93. You're paying for a benefit your engine physically cannot use. This misconception is costing drivers billions every year, and we need to end that right now. Introduce a problem challenge. The core challenge here is that the word premium has been engineered to sound like better. When you buy a premium coffee maker or a premium cut of steak, it is genuinely superior. In the world of gasoline, that is completely false. The problem we need to solve is this. When should I actually use premium, high-octane gas? And what happens when I put it in a car that doesn't need it? Let's start by defining what octane is. Octane doesn't mean more power, and it doesn't mean cleaner fuel. Octane is simply the fuel's resistance to auto-ignition. To understand this, we have to talk about how your engine works. When your piston goes up inside the cylinder, it compresses the fuel and air mixture into a tiny space. This compression is what creates the immense power when the spark plug finally ignites it. The problem happens when that compression gets too high. If the compression is too intense, the fuel can spontaneously ignite before the spark plug even fires. This uncontrolled explosion is called detonation, or more commonly engine knock. It sounds like a nasty rattling noise, and it is absolutely lethal to an engine over time. It can break piston rings, damage valves, and generally destroy internal parts. The job of high-octane fuel, like 93, is to be much harder to ignite. It's stubborn. It resists that intense compression. It is the fuel you use in a high-performance engine that squeezes the mixture so hard that cheap 87 octane would explode too soon and destroy itself. Here's the controversial kicker. If your engine is designed for 87 octane, it simply does not squeeze the fuel hard enough to ever cause 87 octane to detonate. Putting 93 octane in that engine is like buying a military-grade bulletproof vest to walk to your mailbox. It's overkill, and the extra protection is totally irrelevant to the threat level. Your engine can only utilize the octane it's engineered for. We need to go into the details of exactly when an engine needs that stubborn, high-octane protection. Let's break down the only two scenarios where your engine actually requires or can benefit from premium fuel. Everything outside of these two rules is just burning cash for zero gain. Rule 1. High compression ratio engines, the natural aspirated elite. This is the old school reason. Some performance engines are designed with a very high physical compression ratio, the difference in volume between the piston at the bottom and the piston at the top. Think of a big expensive sports car, or some specially tuned Japanese import engines. For example, a typical commuter car might have a compression ratio of 9.1 or 10.1. This is perfectly safe for cheap 87 octane. The engine simply doesn't squeeze the air-fuel mixture hard enough to make the 87 octane detonate prematurely. But a serious performance engine might run at 12.1 or even 13.1 compression. That is an enormous squeeze. If you put 87 octane in an engine like that, it will detonate. The engine will knock violently and the car's computer will detect it. Which brings us to the next critical point. The only way to know if your naturally aspirated car falls into this category is simple. Check the owner's manual. If the manual demands premium fuel, it means the physical compression ratio is too high for 87 octane. The people who drive older, high-end European cars or certain V8 performance engines are the ones who absolutely must follow this rule. Rule 2. Forced induction engines. The turbocharger and supercharger rule. This is the rule that applies to most modern performance-oriented cars, and it's where the technology gets interesting. Forced induction just means the engine has a turbocharger or a supercharger. These components are essentially air pumps that force huge amounts of extra air into the engine cylinders. They artificially raise the pressure inside the cylinder, effectively acting like a much higher compression ratio. Even a regular small four-cylinder engine can suddenly achieve an effective compression ratio of 12.1 or 13.1 when the turbo is fully spooled up. When that turbo is working hard, like when you're accelerating onto the highway or passing a slow truck, the pressure inside the cylinder gets intense. If you've been putting in cheap 87 octane, that fuel might detonate spontaneously under this high pressure. So how does the car prevent engine damage? This is the miracle of modern automotive computing, the knock sensor. The knock sensor is a small microphone bolted right onto the engine block. It listens for the tiny sound of pre-ignition, that destructive knock. The moment it hears it, the car's computer, the ECU, instantly makes two changes. It retards the timing. It tells the spark plug to fire later, after the piston has already started moving downward, which reduces the pressure at the moment of ignition. It reduces boost. If it's a turbo car, the computer reduces the amount of air the turbo is pumping in. Both of these adjustments are designed to instantly stop the knocking and save the engine from itself. This is brilliant engineering, but it comes with a major downside. It completely destroys your car's performance. By retarding the timing and reducing boost, the computer is essentially turning a fast, powerful sports car into a slow, lazy commuter car. You lose horsepower, you lose torque, and you lose throttle response. The bottom line for forced induction. If your car has a turbo or a supercharger and the owner's manual recommends premium gas, you need to use it if you want the performance the car was designed for. If you cheap out, the car will run fine, it won't break down right away, but the computer will keep it choked up, slow, and far less responsive. You are essentially paying for a high-performance car, and then limiting it by 20% to 30% because of the cheap gas. The myth of premium as a cleaner fuel. Now let's tackle the biggest myth of all, that premium gas is somehow cleaner or contains better additives than regular gas. This is fundamentally untrue. In the United States, all gasoline sold must adhere to strict federal standards and contain a minimum level of detergent additives to keep fuel injectors clean and prevent carbon buildup. Furthermore, most major gasoline brands, Shell, Exxon, BP, Chevron, participate in what's known as the Top Tier program. Top Tier is a voluntary standard created by a group of automakers like BMW, GM, Honda, Toyota, who felt the EPA's minimum standards weren't good enough. If a brand is Top Tier certified, it means every single grade of their gasoline, 87, 89, and 93 octane, contains a much higher, more aggressive dose of cleaning detergents than legally required. The important point is this. The cleaning additives are the same in 87 as they are in 93, provided you buy from a top tire station. The only difference is the octane level. If you are worried about keeping your engine clean, you should worry about buying gas from a cheap off-brand station that might not meet the top tier standard, not about the octane number. If you buy top tier 87 octane, you are getting the same cleaning power as top tier 93 octane. The only thing you're missing is the unnecessary knock resistance. You are not buying a cleaner fuel when you buy premium. You are buying a fuel that resists detonation better. For a normal car, that's just a waste of money you could be using for literally anything else. The damage of high octane in low octane cars, the hidden consequence. This is the part that will surprise most people. While putting 93 octane in a car that only needs 87 will almost never cause mechanical failure. It can sometimes cause minor, cumulative performance issues that are hard to diagnose. Since the 93 octane is chemically designed to be harder to ignite, it can occasionally lead to a less complete, slower burn in a low compression engine. This can result in minor power loss and, ironically, in some older or less advanced engines, slightly increased carbon buildup over time because the fuel isn't burning as perfectly as the engine was designed for. The engine's entire ignition map, the timing of the spark, is optimized for that fast-burning, less resistant 87 octane. When you give it the slow-burning 93 octane, The burn time is slightly off, which sometimes leads to a marginal drop in efficiency. It's not engine braking damage, but it's definitely not the better performance you thought you were paying for. You get worse fuel economy, you get marginally less power, and you spend more money per gallon. It's a triple loss for a standard commuter car. You're giving the car a fuel that requires a performance engine to utilize. And since your car doesn't have that performance engine, it just doesn't use the fuel correctly. It's like putting racing slicks on an old pickup truck. It doesn't help. Climax chart key moment. So, let's bring this all together into the single most important action point you can take away from this video, especially if you drive a modern car built in the last 5 to 10 years. The key moment: do not trust the word premium. Instead, you need to find the minimum octane recommendation label on your car. Here is the one sentence that saves you thousands of dollars. If your car manufacturer says minimum 87 octane, then 87 octane is the best fuel for your car, mechanically and financially. If your manufacturer says 91 octane recommended, or 93 octane required, then you must use that higher grade. But here is the trick for 99% of drivers. The engine is smart enough to save itself. If you have a turbo car that recommends 93, but you're just driving casually around town, commuting slowly, and barely tapping the accelerator, you can actually put in 87 octane for that tank of gas and save the money. Since you aren't engaging the turbo, the pressure inside the cylinders never gets high enough to cause knock. The computer won't have to pull the timing, and the car will run perfectly fine, giving you the same power and economy as the 93 octane. But the minute you floor it, the computer will hear the knock and pull power, making the car slow. So the rule becomes, buy high octane only for the performance you intend to use. If you're going on a road trip where you plan to drive aggressively and pass a lot of cars, sure, fill up with 93. If you're just driving to work and back, save your money. The oil companies don't want you to know this simple truth. They rely on your good intentions and your desire to treat your car well. They label it premium, and we open our wallets. But mechanically speaking, the only premium thing about high-octane fuel is the price. For the vast majority of cars on the road, the Honda Civics, the Toyota Camrys, the Ford F-150s, non-EcoBoost, the base model SUVs, the engine can only utilize the octane rating it was built for, and any extra resistance you pay for is utterly pointless. Stop falling for the myth. Conclusion. Summary. We've covered a lot of ground, but the simple rules for gas are easier than you think. Octane, fire resistance to detonation. It does not equal power or cleanliness. Only use premium high octane. If your engine has a very high compression ratio, check the manual. Or if it is turbocharged, supercharged, and you want full maximum performance. If your manual says 87 octane, stick with 87 octane. The fuel is cleaner, burns faster as designed, and is cheaper. Putting 93 in can sometimes be slightly worse for efficiency. Buy top-tier gas. That's the real secret to a clean engine. Buy from a major branded station regardless of the octane number to get the best detergents. By ignoring the confusing labels and just following your owner's manual's minimum requirement, you will keep your car running perfectly, and you will immediately save hundreds of dollars a year. That's money better spent on maintenance that actually helps your car, like high-quality oil changes or getting your transmission serviced. Don't let marketing influence your maintenance choices. Call to action: click here to watch the next video where I break down which oil brands are actually just scams.